Hello guys, welcome back to Mr. Cloudbook channel. Today is the day 37 of the Kubernetes masterclass. In this video, we are going to talk about the vertical pod autoscaler. And yesterday's video, we talked about the horizontal pod autoscaler. And we are going to talk about the VPA vertical pod autoscaler here. And you don't get any questions from this one in your CK exam. That's why I'm not making it more detailed, but I will explain in a simple way. And if you have any doubts on the Kubernetes series, you can reach out here on the Discord. So I will provide the link in the description as well. So we have the general discussions, any tasks, helps, and everything we provided here. So just reach out here. So far, if you have any doubts. So first of all, we will see why we need the vertical pod auto scaling. I will explain in a simple example in a real case. You can easily understand. Imagine a big library where students, I mean your application, come to study. Each student needs a desk, right, to work there on their tasks. Okay. So I have this big library. This is one student. I mean like the pod, or you can call it as anything, application pod or a student's library. So in big library, there are so many desks are there. Each student needs a desk. Okay. So this particular student need a desk, this particular student need a desk, and this particular student needs a desk to work on their task. I mean, like in resource case, this pod needs pod resources like CPU memory, and this one needs CPU memory, and this one needs CPU and memory, right? So every pod needs the CPU and memory. Here the problem is some students are writing the long essays. Okay, so this guy is writing a big essay on some concept particularly. So they need the big desk. Okay, so this guy is writing big essays, so he needs some kind of library books and everything needs to be placed on that particular table, right? So that's why this particular, okay, whatever this particular guy needs the big desk in order to complete his task. So maybe they have the some kind of books for the references and laptops so and so on, and others are just reading a single book. Okay, this guy here is just reading one small book. Okay, he just came just to study the simple novel on the library. So this guy doesn't need big table, right? Big desk. So he can sit on simple desk. But here, this first guy, okay, needs the big desk here. So in order to put his everything, books, references, laptops and everything, okay, big desk we need. So here this guy needs small desk, here we need the big desk, right? The problem is there, okay, but how we have to provide them, okay, you go sit there, you go sit there. We can't say like that, right? So here comes the issue. The library staff means the Kubernetes set up the desks in advance based on the guesses about what the students might need. But sometimes students don't get the right desk size, right? So I am there here. So I know this guy uses the big desk, so I'll provide him big desk. And this guy uses the small desk, so I will provide the small desk to him. So likewise, so not always possible, okay, to give him the exact size of desk in order to complete his task. Okay. A student writing an essay might run out of the space on a small desk, right? Sometimes it will happen. Okay. This guy also started writing the one more novel. So after reading this, he is writing one more novel. So this small desk is not suitable for him. A student with big desk might only use a tiny corner. Okay. So this guy is completed. Okay. This first guy is completed his work and is still using it, that resources and everything. But here there is so much of empty space is there on his table. Okay. See, only this much of space he using and remaining table space is completely empty. And here this guy needs a big space, extra space he need. So here comes the big issue. So we can provide that particular resources, whatever we need to this particular candidate or to the application. Okay. So this maybe sometimes this pod need the high CPU or memory, and later point on it doesn't need it. Sometimes this pod needs the high CPU and memory. So, right? So this is the issue. We can provide them in a simple way. Okay, you are using this. So it will continuously use this disk, right? Once we assigned, it will automatically use. Okay, if I assign, so one CPU directly core to this particular pod, it will use automatically, even if it does not needed. So it will use. So here we are providing the smaller CPU for this pod. Okay, but later on this needs is the highest CPU cores. Okay, which is not possible. So here comes the solution, that is vertical pod autoscaler. The vertical pod autoscaler is like the smart library manager who observes that what each student is doing and adjusts their desk size accordingly. So here how is the VPA works. So monitoring usage, first of all, the VPA watches each student closely. So this will observe these three pods are the three students. Okay, we have the three students in the library for now. So it will monitor these three guys and to see how much desk space they actually using. So it will check, okay, how much CPU usage or disk this particular pod is using, and this one as well, and this one as well. So vertical pod autoscaler will always check, okay, how much actual space or how much actual resources they're actually using. If a student piles up a lot of books and start running out of space, the virtual pod autoscaler notices it. And if another student has a big desk but isn't using most of it, so the VPA notices it that too. Okay. So here what happens? This pod is using the this disk, okay, big disk, and this third pod using the small disk. So here this pod is not using all the resources like CPU and memory usages. It's not using. And but this particular pod, what happens? This needs the more resources. What it will do? VPA always monitor everything. Okay, virtual pod autoscaler will monitor everything, then makes the recommendations. Okay, based on what it observes, the vertical pod autoscaler comes with the recommendation for the right desk size for the each student. This particular student needs the bigger desk and this particular user needs the smaller desk. And resizing, okay, if needed. So whenever this guy completes his work and whenever this guy needs the more desk, the vertical pod autoscaler takes action and changes the desk size accordingly. It gives more space to the students who need it and increase the desk space. Okay. So this guy is completed the everything, resources and everything, his work is completed. So it doesn't need that much of desk. It will recommend to use this particular small desk and give this particular desk to this guy. This third guy needs the bigger desk now. So VPA will recommend, okay, so give this particular desk to that guy so he can use it. Okay. So whenever the pod is needed high CPU usage, okay, so the virtual pod autoscaler will recommend it to use it. So whenever the work is completed, and if some pod needs the help, so it will again recommend this pod, okay, use this much of resources from there, or you can, it will recommend how much resources should use. If it using more than that, vertical pod autoscaler will automatically restore that particular pod. So we have some kind of modes available in the vertical pod autoscaler as well. So it reduces the space for the students who don't need as much as a space. Okay, free up the resources and everything. If resizing requires moving the students to a new desk, the student may need to pause the work temporarily, just like restarting a pod. So we can restart the pod as well. So if we need some kind of recommendations in some cases. So the benefits of the vertical pod autoscaler is no shortages. Student never run out of the space, or pods never run out of the CPU usage or memory usages in their work. No wastages. Desks aren't oversized and resources aren't wasted. So here we don't oversize the CPU or memory, but we will use the resources that are what we provided to that particular node. Okay. An efficient library. The library can handle more students because space is used wisely. So if some traffic is coming to your pods, so it will handles the application without getting downtimed because of we are having the vertical pod autoscaler. It will recommend the how much CPU we need and everything. Okay, so if something needs, it will automatically restore that pod as well. Okay, so here vertical pod autoscaler will give the recommendations to for us. Okay, so in Kubernetes, this means your application always have the right amount of resources to run smoothly and your cluster isn't wasting any CPU or memory. The VPA, vertical pod autoscaler, keeps everything balanced and efficient, just like the library manager keeps the study area well organized. So whenever the CPU, I mean like the whenever the pod needs the CPU or memory, it will recommend, okay, the vertical pod autoscaler will recommend. So use this much of resources, and whenever the work is completed, so it will take back and it will revert back to whatever we asked for the requests. Okay, so we are providing the limits and requests as well in the pod while using the vertical pod auto scaling. Let's see the demo as well. Okay, you can check this one if you need any help from the auto scaler. So let's see the running nodes, kubectl get nodes. So two nodes are running. And first of all, we have to install the metric server. Okay, so because we need this, and let's come here and paste it and apply. So already we talked about the metric server, so that's why I'm not going to explain much about it, and I'll just change the values which are needed to change it, and I will update it vi1.yaml, and we need to change some value. So if you don't understand this particular concept, just watch that particular metric server video and apply it. kubectl apply -f1.yaml. Okay, that is done. And let's see the pods. kubectl get pods -a. So it will start in a couple of seconds. And next come here. So we need to add this one. We added this. Next we have to install the vertical pod autoscaler. See, assuming your kubectl is now targeting the correct cluster, you need to deploy the vertical pod autoscaler and everything. Clone the vertical pod autoscaler repository. So I showed the repository here. This is the one, and I'm doing the same thing here. And I'm going inside the vertical pod autoscaler as well once downloading that particular repository. So what I will do, I'll just copy this commands and let's check the pods again. And the metric server is running. You can check that one. Let's come here, copy the commands again, copy it and paste it here. So it's cloning that particular autoscaler repository here. So I am inside the autoscaler and vertical pod autoscaler, and let's start it. Okay, so we have direct command to start the vertical pod autoscaler. Updating the files, you can see that it will start everything. And if you provide a again, so it will not create. Okay, this VPA is not creates. If you check on completely, it will not create. So you have to check the resources. What is the issue? Use kubectl describe, okay, pod -n, which is running in the kube system namespace, and enter. And here you can see that mount volume failed for volume TLS sets. Okay, this needs some kind of TLS certificates, so which are not found here. Okay, that is the issue. Okay, no matter what, if you try anything, you will face the issue, and that's why I will make it down. I will stop that particular everything the pods for the vertical pod autoscaler and clear it. And I created this one. Create these two files and add the content. Okay, why we are adding this means it's due to your current VPA setup needs a self-signed certificate. Since they are not exist in a VPA TLS certificate, it's giving error. So we are going to create a self-signed certificates. Okay, you can see that open SSL, and we are creating this some DNS records and everything self-signed certificate. So just copy it and paste it here and enter, and come again, and you can see that create TLS means we are creating the TLS certificates. OpenSSL generate RSA certificate like that, and just copy this, come here and paste enter. So it will create the required files, and we have to provide the executable permission for that one, chmod plus x. Okay, and if you see ls, and this is the one we created the file, and run that one. So it will create everything. You can see that generating signature, okay, subject cn, VPA webhook, that is everything it's created, getting private key and everything. And next we need to create this one. Just copy this. So we are creating the generic secret for that particular one. Okay, whatever the key we created certificate, we are creating the secret in order to get the details for your vertical pod autoscaler and enter. Okay, you can see that secret VPA TLS created. Okay, certificates, and clear the screen. Come here, and finally again let's make it up. Okay, again run the vertical pod autoscaler. Okay, you can see that now it's using the keys. Okay, service VPA created and deployments and everything. Just ignore this. We already created it. That's why it's saying already exists. Okay, last time we don't have this one, right? But now we have everything. Okay, let me clear the screen. And if you see kubectl get pods -a enter. See now VPA admission controller is running within the 22 seconds ago without any issue. Okay. Now our vertical pod autoscaler is running metrics server. Let's see top nodes. See our metrics server is also running. How much CPU is taking control plane, a worker node and everything. That is also fine. So no need to worry about everything. I'll provide all these commands. Okay. So let's create a simple namespace. Okay. So API version, kind namespace and metadata. You can directly use the kubectl create ns and give this one as well. Okay. So if I use this, okay, kubectl create namespace ns short form enter. You can see that namespace VPA test is created. So this is the direct command, and create a service. Okay, I'm creating one more service here. I'll just copy this and come here and vi s.yaml simply service. So I'm not explaining all this because everyone knows it. K apply -f s.yaml. Okay, you can see that test service is created, and next we need to create the simple deployment.yaml. That is up to you. Okay, let me copy whatever the name you are providing, that is up to you. So I already talked about this in the, okay, let me copy this 1 minute. So vi d.yaml deployment.yaml and paste it here. And if you go up here little bit, I will explain this. You no need to worry about it. So mostly everyone knows API version kind deployment. This is the deployment.file. Okay. So match labels, test app, everything. I'm using replicas one. Okay, using Nginx 1.19 and container port 8080. I'm exposing this particular container and resources. How much, I mean request. Okay, first of all, whenever the pod is created, it will create, definitely your pod gets the 100 M of CPU cores and 50 MI of memory. Okay, whenever there is high traffic, it can uses up to 200 M and 100 MI. Okay, watch the video request and limits. I already explained, and commands and arguments we will talk in the upcoming session. But this is a simple one, bin sh. So I'm just updating the internal, I mean inside of the Nginx pod, and installing the Python 3 and stress. So just to show the stress. Okay, so k apply -f d.yaml. Okay, that is created. Let's see kubectl get to deploy. So I'm not explaining everything. Deploy -a, and you can see that VPA test. Okay, it's not yet ready. Okay, it's running now. Test app one by one. Okay, clear the screen. So this is a simple deployment.yaml file. I just added extra these lines only, the commands and arguments. You don't need to worry about it for now. And next we need to create the VPA, vertical pod autoscaler. If you see API version, we are using the autoscaling K8s. And if you come here, kubectl explain VPA. Okay, vertical pod autoscaler. Let's try vertical pod autoscaler. See, group is autoscaling and kind is vertical pod autoscaler version v1. That's why we are using the same thing here, autoscaling.k8s.io/v1 vertical pod autoscaler. Metadata we are just giving that one, and namespace we created this namespace at the starting. That's why I provided the same thing. Spec and a target reference. So to which one we need to add the particular vertical pod auto scaling. So I want to add it to the deployment. What is the app name? Test app. Okay, if you come here, clear the screen and get deploy. So what is the name I'm using? Test app, right? For my VPA test, I'm using this particular deployment name test app. That's why I'm calling at the test app here. Update policy, update mode auto. Okay, can be off, initial, recreate or auto. So whenever the pod is using the excess of memory, whatever you provided and whatever we recommended, so it will automatically restore your pod. Okay, so you can check this also. I didn't write about here. So vertical pod modes. Okay, let's check this one. So kubecast. These are the modes of VPA will only provide the recommendation. It will not automatically change resource requirements. And VPA only assign resources requests on pod creation and never change them later. And recreate VPA assign resource requests on a pod creation time and updates them on existing pods by evicting and recreating them. See, auto mode, it recreates the pod based on the recommendation. Okay, so we are using this auto mode. And these are the simple policies. So container policies, how much we are allowing, minimum we are allowing 100 M. So the same thing, 100 M CPU I provided in my deployment, and max allowed use up to one CPU core and 500 MI of memory. So you have to add this all. So minimum how much you are allowing to your pod and everything. Control resources are CPU and memory. Okay, this is the load generator if you want to add a simple one. So it will add the load to your particular pod. Okay, deployment.yaml pod. Come here, va vpa.yaml and come out of it. Okay, apply -f vpa.yaml. Okay, that is created. And the load generator, if you want to add this one, that is up to you. So I'm just adding load generator. You can see the test app. I'm using the test app. I'm giving the load to extra load to my test app pod. Okay, to the deployment. And these are the commands. I provide the each name here also. If you see load generator.yaml, so those are the commands. And let's see the okay pods. Okay, kubectl get pods -n v test. And you can see that only pod is running test app 1, nothing are running, right? Extra pods. And kubectl describe VPA test. Let's see the difference first of all. So kubectl describe VPA vertical pod autoscaler test app, which is in the namespace of VPA test. And you can see that recommendations, it will automatically take these recommendations. Okay, so how much your CPU, I mean the pod using your CPU. Okay, see 78 presently it's using, I think. This one upper bound means to how much it can use, up to one CPU core and 500 MI of memory. So lower bound means this is what we provided. Okay, lower bound means presently we provided, and upper bound means to how much that pod can use the CPU and memory usages. And the target CPU is 100 M, and we have this one presently the target, which is test app, right? I hope you understand about the vertical pod autoscaler. So I'll provide every command, no need to worry about it. And thanks for watching the video and keep on supporting to Mr. Cloudbook channel.